Okay, I wanted to go over a couple of problems that I think y'all asked for in class, and I don't remember if we were able to get through them all. But if you have any other problems after I do these couple, then just let me know soon, and maybe I'll be able to get those up for you before Tuesday. So, suppose that a farmer encloses a corral for cattle adjacent to a river. No fencing is used by the river. If he has 180 yards of fencing, what dimension should he use to maximize the area? What is the maximum area? Okay, when you have a problem that says maximize something or minimize something, that's usually a quadratic function that you're going to get because that's going to be a parabola. And the maximum value of a parabola happens at the vertex if the parabola opens down. The minimum happens at the vertex if the parabola opens up. So we're going to assume for this problem that we're going to end up with we're going to try to be finding a quadratic function that opens down, and we'll look for the vertex. That's the maximum value. So they give us some information. They tell us that there's 180 yards of fencing. So all this fencing around the perimeter here adds up to 180. So 2x plus y is equal to 180. And then they are saying we want to maximize the area. So whatever function we're going to create that we're going to maximize, that quadratic, that parabola, that function has to represent the area of this rectangle. And we know that area of a rectangle is length times width. So our function is going to look like x times y. And we can call our function whatever we want to. I'll call it a of x for area, and that's what that equals. We only want one variable in our function. That should be x. So y should not be there. And so we need to solve for y so we can have only x's in our function. And we'll substitute that in for y. So for y, I'll just erase that y and I'll put negative 2x plus 180. And this will be our function, negative 2x squared plus 180x. And that is a quadratic function, which means it is a parabola, even though it doesn't have a constant term like we're used to. It looks like a parabola. It is a parabola. Okay, and it does open down because you can see that the leading term is negative. That coefficient is negative. So it's a parabola that opens down, and all we need to do is find the vertex of the parabola. So we can use the vertex formula. We don't have to get this in vertex form. We can just use the vertex formula, which is negative b over 2a for the x coordinate and a of negative b over 2a for the y coordinate. Remember, you can remember this formula pretty easily because this is just the rational part of the quadratic formula. And so we've got our quadratic, our a is the coefficient of the x squared, and our b is the coefficient of x, and our c is 0 in this case, but we don't even need c. So negative b over 2a is going to be negative 180 over 2 times negative 2, and that's going to be negative 180 over negative 4, and that is going to be 45 degrees. I mean, sorry, 45 yards. I'm thinking of my circle. All right, so 45 yards is going to be your x. That's going to be this width right here. To find the length, we can just plug that 45 into what we know y is. Y is going to equal negative 2 times 45 plus 180, and that's just going to be negative 90 plus 180, which is, 180, which is 90. So the dimensions that are going to make this have the maximum area are going to be 45 by 90 yards. And to find the maximum area, we could plug 45 into the function for right here. We could plug that into our function a of x. That would tell us the y coordinate of the vertex, which tells me the value of the function, and the function is the area function. So its value will be the maximum area. But why would I do that when all I have to do is multiply 45 by 90? I don't really need to plug it into the function to find that maximum area. So if I just find 45 times 90, that's going to be 4,050 square yards for that maximum area. So this is part B, and this is part A right here. Okay, so I also wanted to do one of these vertical motion problems just to make sure everybody is good with that. So suppose that a rocket is shot straight upward from ground level with an initial speed of 98 meters per second. Write a model that represents the height of the rocket, S of t, in meters, t seconds after launch. Use the model S of t equals negative 1/2 gt squared plus v sub 0 t plus s sub 0 with g equals 9.8 meters per second squared. So when will the rocket reach its maximum height? This is just like the problem we did before, except the formula is different, but we still get a quadratic function, which is a parabola, which opens down, and so therefore the vertex will have the maximum value of that function. So we're just going to fill in everything into the function and then find the vertex. We've got negative 1/2. When you're talking about meters, your acceleration due to gravity is 9.8, and then t squared plus your initial velocity is 98 meters per second. So that's your t coefficient, and then the initial position of it said ground level, so that's just 0. It wasn't shot from somewhere above that; it was shot right from the ground. Okay, so again, you've got this parabola. We can kind of fix this up. This is going to be negative 4.9 t squared plus 98t. And we can just put this into the vertex formula, which again is negative b over 2a. And then it would be s of negative b over 2a for the position. So this is your a and this is your b. And so negative b over 2a is going to be negative 98 over 2 times negative 4.9. And so that's going to be negative 98 over negative 9.8. So that will be 10 seconds. That's how long it will take the rocket to reach its maximum height. So we know the time it takes to get to the maximum height. And now we want to know what is the maximum height. And that's just going to be the value of the function at 10 seconds, which is s of 10. So s of 10 is going to be negative 1/2 times 9.8 times 10 squared, which is 100, plus 98 times t, which is 10. If we punch that into our calculator, we're going to get 490 meters for the maximum height. Okay, so D says determine the time interval for which the rocket will be more than 200 meters high, round to the nearest tenth of a second. Okay, so we have a quadratic inequality now. We are trying to figure out when our function, negative 4.9 t squared plus 98t, is greater than 200. And so what we want to do is we want to find out when the function equals 200 to start with, because if we think about it, we've got this rocket, it goes up, and it reaches its maximum at 490 meters, and then it comes down. So up and then down. And so at some point, it's going to pass 200 meters on the way up. It'll hit 200 meters, and then on the way down, it will also go past 200 meters high. So we can find out, first of all, when does the function equal 200? When is the function actually at 200 meters? And so if we know that, if we know how many seconds it takes the rocket to get to that point at 200 meters, and at what time will it be passing 200 again on its way down, then we know the time in between those two times is when it's above 200. So we will solve this function. We will find the zeros of this function, and that will tell us when negative 4.9 t squared plus 98t is equal to 200. So we're going to plug that into the quadratic formula. So we're going to have negative 98, so negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's going to be negative 98 plus or minus the square root of 5,684 all over negative 9.8 And if you do the math, if you punch that in your calculator, the two values you'll get for plus and minus, you'll get about 2.3 seconds and about 17.7 seconds. So the first time is when it passes on the way up, and the second time is when it passes 200 on its way down. And so we know that between these two times, that's when the rocket will be above 200 feet.